Hey guys, welcome back to Rocket Gyan, my fellow space tubers. And whoa, today we are back with yet another launch, and this time from other than Rocket Lab. And boy, they are doing some amazing work. Um, but today it's a special one because this will be the second launch of the Rocket Lab from the USA, and that too from Virginia. So all of the people out there watching it, this cool mission, this cool rocket launching in from the kind of your backyard only, right? I'm so jealous of you. But today we'll be seeing how good this rocket will perform and what all things it actually is carrying, and what this company is all about. And if you haven't heard about them, then whoa, yeah, see this one also, this thing which you're seeing right now, this is the neutron rocket which they are making, and this one also will launch from the Virginia, Wallops Virginia itself, and uh, that is kind of a reusable rocket which they are making. It's a cool looking rocket. We'll talk about it when that launches. But today, this rocket will be launching the Electron rocket. So uh, we will talk about the Electron rocket. But how are you guys? Hi, Angel. Welcome to the stream. Barbara watching from WV. Okay, cool. Great. Thank you so much for tuning in. Hi, Nicole. Hi, Wildflower. Yes, Ada, it's 3 a.m. here. No, it's 4 now. It's about to be 4 now. uh, Hi, Arvil. I hope you all are doing great. Um, and let's just jump into it, right? Let's just see what this mission is all about, and let's just get to see this stronger together mission. So first of all, let us have a quick look at the rocket itself. So this is in front of you, a 3D model of a rocket, and this rocket is kind of a cool looking rocket. So I'll tell you why. So this is first of all a two-stage rocket, and the first stage is powered by, you can see, the 9 engines, and none other than the 9 Rutherford engines running on electric pump fed cycle, which is unique in its sense only. Then the second stage is also powered by one Rutherford engine, but that is like a vacuum optimized engine. But yeah, so the first stage produces around um, 24 kilonewtons of thrust per engine, so 9 times 24 kilo, and has a specific impulse of 311 seconds. The second stage has it has one engine only and produces thrust of around 25 kilonewtons and ISP of 343 seconds. So when you compare about the ISP, right, with the rockets which we already have nowadays, it's kind of on a lower side, uh, but still it gets the job done. But one thing which I don't like about this rocket is its price. The cost per launch is too much. It's like $7.5 million per launch for putting around 300 kilograms to the orbit, to the low Earth orbit, not even the sun synchronous. So kind of on a costlier side, but it gets the job done. And the best thing to back for the Rocket Lab is its launch cadence. So yeah, so talking about the fuel, it uses that SpaceX fuel only, the RP1 and LOX. And yeah, so we should say that should be the rocket itself. We shall move on to the next one. Maybe we need to have a look at the other specs also, right? Yep, this was launched CB Manly. Hey JDJ. Hi Jane, how are you in Virginia Beach? Well, if you are seeing this rocket, then get ready to be very excited, because dude, this rocket is gonna be one of its kind. And you will be seeing the rocket, you know, when you'll see the rocket, if you are seeing it in person, you will know. Although it's a tiny and cute little rocket, but it does make some sound. Fine. Okay, now let's have a look at the specs. So first of all, let me move on to one thing which I wanted you to see is this one: 3 dedicated launch pads. So they not only have one launch pad which is in Virginia, but they also have launch pads in New Zealand. And yes, if you are tuning in for the first time, New Zealand was the primary launch site for them. So they have 2 launch sites in New Zealand. Although this company is based out of US, but they had a launch site in the New Zealand. So primary one is there, and now recently only this is the second launch from Virginia. So recently only they acquired this Wallops launch site, and they will be using it. And yes, this is the only reusable small launch vehicle. Although today in this launch they won't be reusing this rocket, but yeah, there is that. It can carry around 300 kilograms to the low Earth orbit. These are some quick facts. The height is around 18 meters or 59 feet, or you can say if you see a 6 feet man, you can stack 10 people all over him. So that is actually the size of this rocket. And yes, it uses carbon composite, which is itself unique. Today we don't have a kick stage, so there is that. We have already talked about the engines. 9 Rutherford engines powered by RP1 and LOX. So the plume looks very much similar to the SpaceX Falcon 9, which it should be. And yes, the reusability, they have a very unique plan to catch the rocket with the help of a helicopter. When they reuse although that is still in research state, they already have demonstrated multiple times recently only for the reusability capacity, but they are not doing it full time right now. That's just a part time. So once they are confident enough, we'll see that. Okay, fine. Now let's move on to the next thing, which is the payload. So the payload which it is carrying, we'll talk about this later. Yeah, this satellite, this cool looking satellite, isn't this cool, right? Now you must be wondering, wow, this looks like a big chunky piece of metal. Now how could it fit inside the fairing? So yes, it's kind of very big when it opens up, but it is all closed up right now. This is the thing which you are seeing right now here, this kind of umbrella kind of thing. It is actually a mesh. And whenever you see such a mesh in a satellite now, then just remember that that's a SAR satellite. SAR satellite is nothing but a synthetic aperture radar, which is very useful in capturing the earth features, even though there is a storm coming in, or the baddest weather you can have. No matter how bad the weather is, this satellite will scrape the earth's feature and get you that juicy little info which you need during the disaster management, right? So yes, so this is a satellite which is so first of all, the mission which is going on is known as Stronger Together. Okay, and they will be placing two satellites into the orbit. What is the orbital characteristics? I'll talk about that. So those are the two SAR satellites, and these two SAR satellites will complete the uh, Capella Space second generation of SAR satellites. So this is the second generation of Whitney satellites, which is Capella 9 and 10, which is going to launch today. And they are nothing but a synthetic aperture radar Earth observation satellite. So they were going to map the Earth's surface with its radar feature. So what happens in SAR is they send out a frequency to the Earth. It hits the Earth and then gets bounced back. And this large metal mesh which you are seeing in front of you, it catches that frequency and then it analyzes the Earth feature. So that is the reason why it's much better than optical one, because here you are actually sending a frequency which can penetrate that clouds and bad weathers and get you that information. So right now in second generation satellites, the ground resolution is 0.5 meter per pixel, which means every pixel which you see in with the help of this satellite is 0.5 meters. Now after this they will be launching this one in front of you. This is the third generation of satellite. This is not launching today, but this constellation is gonna complete the second gen, so the third gen will come into place. And the thing is that this will have a 0.3 meter pixel resolution, and this will be named as Acadia. Not only this will also feature some system upgrades, which will be like an inter-satellite laser link terminal, which will enable them to use their satellites as relays to provide images of observed areas in under 15 minutes. That is the main thing. These private companies are relying on getting the data as quick as possible, because the government agencies, NASA, ISRO, whatever Earth observation, ESA satellites are launched by these orgs, they are just a single one. They don't launch constellation wise, and those are mostly allocated for research. When you have to have data for actual analysis, right, for disaster management and all, you need quick response, quick data, and these companies are helping in those things. So yeah, so this is pretty much about the company. If you want to visit their website, this is their website. Capella Space, most advanced SAR satellite designed and manufactured in US. This is how a SAR satellite data looks like, although it's obviously all the numbers are analyzed to make a image out of it. And this is the famous Palm Island of which you can see in front of you. So this in SAR now you actually get to see the features, Earth's feature, because the 3D features of the Earth, because you can actually map the distance precisely with the help of that frequency. So yeah, so this is the thing. We can now move on to the next one, which is the orbital characteristics, what this mission is all about, right? So this mission is gonna launch from Launch Complex to Wallops Island, Virginia, going to a 600 kilometer circular orbit with an inclination of 44 degrees, which is very much similar to what ISS has. So it's not going to a polar orbit, it's more of a low Earth orbit only. It is carrying two satellites, both from the Capella Space, and we have already talked about this. So the Launch Complex 2, which is from where it is launched today. So this launch pad not only will feature the Electron launch, but in future the Neutron launch, which is a cool looking rocket. I'm telling you that it's gonna launch today and you would love it. You would totally love it. I'll talk about the viewing criteria where you can have a look at it, but so yeah, here you go. So people who are living nearby, and if you want to watch this launch, so here are the directions to the places where you can go and watch this one. And if you are living in your houses but near the launch pad but don't want to go out, I'll have you covered also. So take a screenshot or something like that, and you can have a look at the launch from these locations. Okay, so the mission timeline would look like this only. So first of all, liftoff will happen. Then the me it will reach the max Q. Then it's a typical launch profile. The MECO, the main engine cut off. Then the stage separation will happen. The second engine start will happen. Then the fairings will be jettisoned. Here you can see the fairing separation will happen. Then the battery jettison will happen. Yes, this is kind of an electrical powered rocket. Electrification in rockets also. So there is a battery which is actually running the turbo pumps in here. It's an electric pump fed engine. So this engine is using electrical power to run the turbo pumps, turbines, which in turn runs the turbo pumps. So it is reducing all the complexities in pipes and mechanism and mechanics and fluids and whatever you want to say, right? Which is actually needed in a small sat launcher. You don't want to complexify everything. Yeah, stage 2 engine cutoff will happen, then the stage 2 SEP, and then so we have a kick stage here also. So in the kicks we will be having two kick stage engine and the engine ignition and the kick stage engine cutoff, and then the payload separation. So this is how the rocket would look like with the kick stage. I've already talked to you about the first stage and the second stage already. The kick stage is nothing but kind of a tug stage, which is responsible for fine tuning the orbit as well as getting into the desired orbit for the two satellites which they want. Okay, this is mostly added to if the rocket is not carrying like too much weight, right, then it can add a kick stage which will be nothing but a tug stage which has a fuel and an engine in it to increase the delta V, or how far you can go, because you are technically adding a rocket stage to it, right? So if you want to reach a higher orbit, which is what they are doing today, 600 kilometers with a lesser payload mass, right? Then they can include that, and that's what they are doing it. So yeah, that is pretty much about it. Now for you folks who are sitting at home and wanna have a view from their balcony, so this is the launch view area which you can see. So here you can see from, if you are in the launch side area here, in 0 to 30 seconds this blue picture will be blue area will be visible. From here you can see the launch. Then after 30 seconds it will be visible in green. Then after 60 to 90, this yellow, pink, blue and orange, and so on and so forth. So this is for you guys who are sitting at home right now and wanna watch this beautiful launch going into space. All right. Let me see if I have the live stream already. I'll switch over to that. Nope, still waiting. So okay, yes, we are waiting. Okay guys, if you have any questions or something, some questions for me or feedback, you can totally and definitely type in the chat. I'll take your questions. And if you want to if you are new to this channel, guys, I just want you to know that we cover all the launches, most of the launches that happens in the space industry. It's more like a unique launches which you don't find in any channel. So if you are a space fan, rocket fan, you can consider subscribing and leave a like if you haven't already. So this is the launch view area which you can have a look at. So let me give you a reference, like how do you use this kind of a map to view how to view this one. So if you, let's say if you live in this Trenton region, then you need to look in the southern direction. Okay, so this map actually points out from where do you have to look exactly to view the rocket. You need to look in the south. If in Pittsburgh, you need to look in roughly southeast. Yeah, if you live in Raleigh region, then you need to look in northeast region. So accordingly you can figure out where to look and when to look with the help of the colors. Okay, yes, thank you so much, Erwell, for that notification. Yes, for anyone watching in a distance, keep in mind there's a delay. Yep, so there will be a delay in the stream, but you shall go and so you just go at T minus 5 minutes. That's it. Go at T minus 5 minutes and enjoy the launch. That's a cool looking logo, right?
Good evening and welcome to the live broadcast for our 34th Electron mission, a launch we've called Stronger Together for our mission partners Capella Space. We're bringing you a live view of Electron on the pad as we prepare for our second launch ever from our dedicated launch pad in Virginia at Launch Complex 2 on Wallops Island. My name is Felicity Powell.
And I'm Likita Satosala, and we're so glad to have you with us. We're about 16 minutes away from our target liftoff time of 1800 Eastern Local Time or 2300 UTC. It's hard to believe it's been just over 6 weeks since our very first launch from our dedicated launch pad at Wallops. On January 23rd, we launched to space from LC2 for our customer Hawkeye 360 and delivered their satellites to orbit with pinpoint accuracy. Those 3 Cluster 6 satellites are already providing useful Earth observation data from their new home in space. That mission marked a new era of dedicated small launch from U.S. soil for satellite operators. With the support of Virginia Space, the Commonwealth of Virginia, and NASA Wallops Flight Facility, we built Rocket Lab Launch Complex 2 to serve the responsive needs of the future and to offer ultimate flexibility for our customers, enabling them to launch from one of 3 pads across 2 continents. Combined, there's the possibility of more than 130 launch opportunities every year.
We also operate an integration and control facility within the Wallops Research Park, a short drive from the pad itself. Our facility is home to payload integration cleanrooms, vehicle processing facilities, and a mission control center. The launch pad and production complex for Rocket Lab's large reusable Neutron launch vehicle will also be located here in Virginia. It's yet another way that we're streamlining operations across small and large launch as we build out the future of responsive space from Wallops. Construction is currently underway on the Neutron production complex and its launch pad, right next door to where Electron is currently standing. In fact, while we're preparing to go to orbit today for our customer Capella at Launch Complex 2, across the world in New Zealand at Launch Complex 1, preparations are already underway for our next launch for another customer. Our teams at both sites are looking forward to a busy year ahead. Speaking about being stronger together, though, today from Launch Complex 2, we are launching a dedicated mission for Capella, a leading provider of commercial synthetic aperture radar, or SAR, imagery. SAR is a form of radar that is used to create 2-dimensional images or 3-dimensional reconstructions of objects, such as landscapes. We launched one of Capella's very first SAR satellites on another mission back in August 2020 on our 14th Electron mission called I Can't Believe It's Not Optical.
Our mission today would deliver 2 more of Capella's latest SAR satellites to orbit, enabling them to deliver the highest resolution, highest quality SAR imagery commercially available, empowering organizations across the public and private sector to make informed, accurate decisions based on what is happening across the Earth at any given moment. Here's more about Capella.
Alrighty. Yes, guys, it's gonna launch soon. Till 14 minutes, so you are early.
Command, do you have any questions? Let's rock and roll.
We learn really fast, and we build satellites here in San Francisco. We learn things quickly. We go back into factory, and we make changes, and we go back to the launch site and launch new satellites. There's one team and one company in the world that could do this. It's this team and it's this company, it's Capella. And that's why we're the first and only American company that's ever been able to do this. I mean, we were the first American company to put a commercial SAR satellite. We're the highest resolution SAR imagery in the world in the most compact form. We're the first one that's able to do real-time tasking, which means people are going to be able to get their imagery as quickly as it's possible. So it's not just that we've done something as complex as putting a satellite up, we've put up the best satellite in space. So, and we've done that with just 100 or so people in a very short amount of time.
We're thrilled to be flying Capella once more and grateful to have signed an additional multi-launch deal with them coming up in 2023. These 4 missions are planned to lift up from one of our 2 pads at Launch Complex 1, with the flexibility to launch from right here at LC2 in Virginia, if campaigns require. All right, as we approach T-minus 12 minutes to liftoff, our operators will run through the final go, no-go poll by this mission's launch director. Let's hand over to Mission Control and check in on how we're tracking for launch. We'll be back with you shortly.
Cool. So guys, yes, this company is kind of older one.
This is the LD on countdown.
March 2016.
Poll for launch, go, no-go sequence, stage.
Stage is go.
Avionics,
Avionics is go.
GNC,
GNC is go.
VCon,
VCon is go.
T1,
T1 is go.
GC,
GC is go.
PLS,
PLS is go.
Mars CE,
RCE is go.
Mars Ops,
Mars Ops is go.
Mars 1, and NASA GSO,
GSO go.
and NASA RSO,
RSO go.
MM,
MM is go.
and LD Sub,
LD sub is go.
and NASA TD.
TD go.
The go, no-go sequence is complete. We are T-minus 11 minutes, 9 seconds and counting. We are go for terminal count at
Yes.
T-minus 10 minutes.
And
From this
we
time, the 3-word
are-
hold procedure is in effect.
Go for the launch, guys. And yes, this audio go, no-go poll.
As we approach T-minus
Nothing can beat
10
this.
minutes and 40 seconds, Mission Control are reporting all systems on the vehicle are healthy and will be proceeding with the remainder of the count. We are still targeting liftoff at 18:38 local time or 22:38 UTC. Now, the satellites we launch open access to space to improve life on Earth. We're also on a mission to open access to the space industry through our global education programs designed to support young people to reach for the stars no matter where they're launching from. We work with schools and other organizations to deliver education programs that inspire, inform, and involve kids in the future of space and STEM, from elementary through to college level. Our flagship program is, of course, the Rocket Lab Space Ambassadors, which Lakita has been involved in for over a year now.
That's right. As a space ambassador, I've received training and resources to travel to different regions, visiting schools and community
Yes,
organizations.
Whitney, it will be visible from the West Virginia. Let me quickly share you the launch view map. Here you go. So this is the map, guys. If you haven't, if you live nearby, this is the map which you need to follow. Like for the pink region, the rocket will be visible at around T plus 90 seconds, and accordingly you can have a look at it, take a screenshot, and if you live nearby, please go check it out at T minus 5 minutes, because there will be some delay in the stream also, and you should go and check this out. This rocket is gonna be amazing.
Teachers and education leaders to deliver engaging space learning experiences. One of my personal favorite programs is, of course, Rocket Club, an after-school program where young Rocketeers learn how to design, build, and launch their own model rockets with the support of our very own rocket engineers. We do have programs for kids aged 8 to 18 and beyond, and these are all offered through our network of over 500 Space Ambassador schools. It's free to register your school, college, or community group on the network so that you can access Rocket Lab's education programs as well. Go to rocketlabusa.com/education to find out more about Rocket Lab's global education programs and see how you can get inspired, informed, and involved with what we do.
Well. Yes, then this outreach of education, especially in rocket science, now it is so necessary. And I really love that US has this model rocketry culture, which is so good. It's just so good to have hobby to build rockets. How cool that is that. And but that is simply not accessible or not a culture in other countries, which is too bad. But yeah, that's how it is. So we are T minus 8 minutes from the launch, guys. Everything is green. The range is supporting, the weather is green, and the rocket is healthy. We shall see this rocket fly in just about 7.5 minutes from now.
Thanks for joining us for this Stronger Together mission for Capella Space. We've come a long way from our first Electron launch in 2017. Rocket Lab started off with rockets as a small launch services provider, and we have now launched to space 33, nearly 34 times for our customers. Now we're also developing our large lift vehicle Neutron, and we have expanded our production capacity
Just
to
look at
in-space
that.
technologies. Through the acquisition of leading aerospace component manufacturers and the expansion of our teams across the United States, Canada, and New Zealand, Rocket Lab is making it easier than ever to get your idea on orbit. Here's Julie Kelly, Business Development Director, speaking to the exciting possibilities for Rocket Lab's Space Systems Division.
I hope this shows some glimpses on the Neutron rocket development. That is one of the coolest rocket that I have ever seen.
My name is Julie Kelly. I'm the Director of Business Development for Space Systems for the Composite segment. So Space Systems is Rocket Lab's operating segment, including a wide range of spacecraft components, solar power solutions, separation systems, star trackers and reaction wheels, command and control software, X-band and S-band radios, as well as composite structures. We got into space systems to provide a vertically integrated solution for our customers. Our Space Systems division allows us to provide the Photon family of satellites and a range of satellite components to bring constellation volume and pricing to our customers. Space Systems heritage includes over 1,700 spacecraft on orbit with a Rocket Lab component.
Yep.
Some of the major missions that Space Systems has contributed to include the Mars InSight rover, Mars Ingenuity helicopter, NASA's James Webb Space Telescope, OneWeb's 600 satellite constellations, which brought global broadband connectivity, and of course NASA's Capstone mission, which was a pathfinder to Artemis's mission to the moon.
Just wow. Okay, so this Space Systems is actually nothing but, I'll tell you.
Able to scale the Space Systems company in a number of ways. So first and foremost is a shared set of knowledge. So we've been able to use cross-collaboration for best practices, streamlining manufacturing. We've added manufacturing capabilities at a number of sites, as well as new product development. So we have one of the lightest, most efficient solar cells in the industry. We're working on next generation separation systems, expanding our reaction wheel portfolio, and investing into next generation products as well as new products. Rocket Lab is an end-to-end space company, and our goal is to provide a streamlined access to orbit for our customers.
Yep. So these space systems are nothing but as the name suggests, systems used in space. So systems used in satellites.
We do together. If you want to be a part of that, there has never been a better time to build your career in space with Rocket Lab. We have plenty of job vacancies open at all of our 9 global sites, so check them out at rocketlabusa.com/careers. At just about 4 minutes to liftoff, we are approaching the handover to Electron's countdown auto sequence. At this point, Electron's flight computers take over the launch countdown. Our mission operators are reading the launch vehicle and payload as healthy and progressing through the count nominally. The weather is still looking good for launch at 2300 UTC. Moments after Electron has switched over to auto sequence, at about T-1 minute 30 seconds, we should hear the call that LOX loading is complete on the vehicle. At 1 minute to liftoff, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch. At T-10 seconds, you will hear our launch director, Joseph Carpico, make the iconic count to 0. Let's hand over now to mission control and listen for these checkpoints. We will check back in with you shortly after liftoff.
Cool. So here you go, guys. We are already under 4 minutes. And if you are just tuning in, let me just give you a quick glimpse of this mission. So The mission is named Stronger Together, carrying 2 satellites for the Capella Space, having a SAR payload, which means the Earth observation satellites, but can also observe Earth in bad weather. And this is a Electron rocket in front of you. It's an all black rocket. The white thing which you see on the rocket is nothing but the ice. It's a 2-stage rocket. First stage, 9 engines, powered by 9 Rutherford engines, RP1 and LOX as its fuel. The second stage powered by 1 Rutherford vacuum optimized engine, RP1 and LOX as its fuel. And yes, it also has one of the unique features that it is an electrical rocket, kind of uses batteries, so it will also do a jettison of that. So look out for it.
Thank you. All operators LD on countdown. From now on, there should be no red flags on your critical LCCs. VCON LD.
LD, VCON.
Confirm all expected flight computer ASGOs are green.
Confirmed.
VCON, lock auto sequence and confirm.
Auto sequence locked.
All operators, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
LD is go for the launch. Launch director has given the approval, guys. We are going. And for one last time, I am sharing you the launch view area, guys. Go outside right now. There will be some stream delay, so just look out using this map. Take a screenshot, and if you live nearby, do check out this cool launch which is happening. So T-minus 1 minute, 50 seconds remaining. Everything is good, and boy, I am so excited. If you are guys, and do give your best wishes to this rocket by hitting that like button, and we hope that this cute little rocket will do its job effectively. I guess silent before the storm.
Anti-geysering is disabled.
T-minus 60 seconds remaining, and this is a silent before the storm.
Stage 2 press for flight.
Tanks are being pressurized. Everything
High
is
flow engine purge enabled.
looking good. Pressurized tanks will always help this cute little rocket. And oh, this is happening. Go out right now. Might have already been launched. You never know. T-minus 30 seconds remaining.
T-minus 20 seconds and counting.
T-minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11.
9, 8, 7, 6, 5, 4, 3, 2, 1.
Ignition.
We have liftoff.
Stage 1 propulsion is nominal.
Beginning pitch over.
Look at that. Beauty go. Wow. That was something. Now it's doing a pitch over maneuver. The next event is
And
the
we're
Max
flying.
Q.
Our 34th Electron
Look
vehicle
at
is in
that.
the air and
Beautiful
on the way to
Virginia.
orbit after lifting off from Launch Complex 2. You can see the exhaust from those 9 Rutherford engines glowing
burn
bright
out
as they
stick mode.
propel the vehicle with Capella's satellites to space. Now that Electron has left the pad, its next milestone is Max Q, the moment when the density of the air around the vehicle and its acceleration through that
battery
air
discharge
creates
is
the
nominal.
maximum aerodynamic pressure that the
Vehicle
vehicle
is
will
supersonic.
experience in flight. You'll hear Mission Control announce this
Stage 1
milestone
propulsion is
soon
nominal.
enough.
That was amazing. So Max Q.
Approaching Max Q.
Max Q ensures the vehicle passes the structural integrity test.
Saying Max Q.
Passing Max Q, engine throttle down at this time so that it does not stress the rocket too much.
From our mission operator's call there, Electron has now passed through Max Q. The vehicle has throttled back up to a velocity of over 1,000 meters per second, just a fraction of its maximum velocity as it proceeds to orbit. We're about to reach another 3 milestones in the flight, and each will happen quite quickly, so we'll explain all 3 in one go. To start,
Hey,
we need to
look at that
separate the
plume
first stage of the
expansion.
vehicle from the second and third stage, also known as the kick stage, which holds Capella satellites. The first stage is essentially a large fuel tank. Once that fuel is depleted, we jettison the tank so that the second stage can carry on to our
Guidance
orbital
is nominal.
destination. To separate cleanly, we need to throttle down those 9 Rutherford
25
engines on the
seconds
first
remaining.
stage. This is known as main engine
Stage 1
cutoff, or
propulsion
MECO for short.
nominal.
Once these engines have throttled down, the first and the second stage separate. Next, you'll see the vacuum optimized Rutherford engine ignites to carry the second and the
Please
third
stand by
stage
for MECO.
the rest of the way into space.
Hey, this is something, and it's coming up for the MECO guys. The plume has gone.
MECO
Ooh,
confirm.
look at that engine bay. MECO stage separation and
successful.
Stage 2 ignition.
engine ignition. Whoa! Look at that view.
MECO, stage 1
Guidance is nominal.
separation and stage 2 ignition confirmed and completed. Our 34th Electron
Stage two
mission is
propulsion
progressing
nominal.
nicely, and we're ready for the next set of checkpoints in flight on the way to delivering Capella satellites to their place in space. We are listening for the call to confirm that Electron's
HVB
fairing,
battery
the
discharge
pointing
nominal.
protective shell at the top of the rocket, has been jettisoned to expose the satellites in preparation for deployment.
It's gonna happen anytime soon now. The fairing jettison. We shall see that on our screen too.
Fairing jettison succeeded.
There you go. See those flappy little birds.
You can see it there on your screen. That's confirmation that the payload fairing has been successfully jettisoned and Capella satellites are now exposed to space. Electron's second stage is continuing to orbit, traveling at speeds of over 8,000 kilometers per hour and currently at an altitude of over 100 kilometers.
That's another milestone checked off. The fairing is a millimeter-thin shell that serves a vital role, protecting the payload's inside from the awesome aerodynamic forces it sees as it breaks away from the atmosphere. Now that we're in free space, we can shed that extra weight to help maximize Electron's acceleration into orbit. Sitting on top of Electron, each payload might feel up to 8 times its own weight due to those
Stage
smooth
2 propulsion
accelerations.
holds nominal.
As part of the structural analysis team, our job is to prove every component on the vehicle is tough enough to withstand the stresses of all those forces, pressures, and vibrations on Ascent, while still being a lightweight and elegant solution.
Whoa, just a millimeter thin, dude. I did not know about that. That is some next level optimization in weight. Just a millimeter level, a millimeter thin fairing. Wow, I can't like even imagine that thin thing to be a fairing because I can just squish it and it actually just withstand those
Discharge nominal.
ultimate rocket vibration as well as stress test. So kudos to them. So right now everything
T+5
is
minutes, and it's
looking
time
good.
Checkpoints in flight as we progress towards mission success. Next up is a milestone unique to Electron, the battery hot swap. You might already know that our 3D printed Rutherford engines are also distinct for another reason. They are powered by electric pumps. These pumps are powered by batteries, which eventually run out of juice. This is where the battery hot swap comes in. We need to swap the used batteries out with another fresh battery and jettison the expended ones to free up some weight, all while keeping that stage 2 engine running smoothly, which is why we call it battery hot swap. Sometimes you can catch a glimpse of these battery packs falling away, so keep an eye on the right side of your screen. While you do that, we'll listen in from the call out from mission control.
Yep. Those right side of the screen, those silvery looking box kind of thing, right? Those are the batteries.
Discharge nominal. Approaching hot swap in roughly 30 seconds.
Hot swap is nothing but they change to the new battery pack and jettison the depleted battery pack. So kind of a thing which they do, and yes, they need to have.
Throttling down.
Okay, look out for that jettison. There you
Hot
go.
swap successful.
Oh, look at that. I also had a glimpse of the second one.
Stage 2 propulsion holds nominal.
So if I remember
Second stage
correctly,
is now running on a fresh battery. You saw it there, with the battery hot swap confirmed successful by mission control. We're in the stage 2 burn for a few minutes longer, but the next major milestone we have is SECO, or second engine cutoff. Similar to MECO, which happens before first stage separation, SECO is when the Rutherford engine on the second stage will shut down just before the second stage separates from the kick stage, which of course will continue on to payload deployment.
don't worry about the visuals. That is mostly a camera flare. That's it. Okay. And yes, what was I saying?
Now it's 7
okay.
minutes and 10 seconds into Stronger Together mission for Capella Space, the second launch from our US launch site on Wallops Island, Virginia, with 4 minutes until SECO and kickstate separation. Electron continues to make its way to orbit, currently at an altitude of 6,000 meters per second and a velocity of over kilometers of around 200 kilometers, over 6,000 kilometers per second velocity.
Yep, and they have for some reason hidden the velocity, but yeah, finally
Propulsion still nominal.
it's nominal. That's what we want to hear. And yes, what I was saying is this battery hot swap, which they do know, that is a critical step, because one of their rockets failed during this maneuver. So they did have some complex thing going on there too.
On time at 18:38 local time and passed through max Q, MECO, first stage separation and second stage ignition without any event. Of course, recently we've just had the battery hot swap and we're just waiting on SECO, second engine cutoff, before the kick stage separates from the second stage.
Cool. It's not like in games, when we have to fight the enemy and we, rather than reload, it's better to switch to secondary. It's always faster to switch to secondary, right? Here it does not happen, because if you lose the power to the engines, then it would be disastrous. So they have some certain complex things which are going on, in which the battery, before the hot swap happens, the electricity is already flowing from the second battery pack, even though the first battery pack has not fully depleted, so that the continuous flow of electricity can work. So yeah.
Let's listen in for SECO and kickstate separation.
All right, things are looking good.
SECO confirmed.
SECO confirmed.
Nominal transfer orbit achieved.
Which you shall
Stage
see.
3 separation confirmed.
Nominal transfer orbit achieved.
The space-optimized Rutherford engine on Electron's second stage has now throttled down, and the second stage has cleanly separated from the kick stage. The SECO and second stage separation milestones for this mission are complete. The next phase of the mission takes a little longer than that action-packed first 8 minutes after launch, but it's worth the wait. Electron's kick stage, with payloads attached, will now enter the coast phase that Lakita mentioned, as it propels the payload in an elliptical orbit towards the apogee requested by our customer, Capella. Once it has arrived at the requested orbit, the small but mighty Curie engine on the kick stage completes one final injection burn to raise the perigee of that elliptical orbit so that the orbit is circular. After circularizing this orbit, we can then deploy Capella's satellites and wish them well as they settle into their new home in space. We will have a simulated view of this payload deployment, plus live feeds from mission control, so stay with us on this webcast. We'll be back with you at T+51 minutes. See you soon.
All right. They need to burn a dirtier fuel? Well. That's not how it works in rockets. In rockets, you need a cleaner fuel than anywhere you will find. So this RP1 is actually nothing but a rocket grade kerosene. Okay, it's not. It's even more filtered than a jet engine fuel. So they need to squeeze out every bit of power from those fuel tanks, right? Cool, right? The launch was very cool indeed, and here you can see certain what should I say, red circles here, right? I guess that is nothing but the ground station coverage. So it's right now in the area of Europe ground station coverage, and then finally it will go towards the Africa and so on and so forth. So yeah. Now what will, so they do this, guys. So this is what they do. They don't want us to see their kick stage. This is some of the thing which they don't want us to see. That is more likely a proprietary piece of hardware which they just don't want to really reveal. If I remember correctly, we haven't actually seen in the proper hardware pics of the kick stage, the actual real pics, which we have seen all the simulation animations as well as some visuals of the kick stage too, but not the actual like proper like what we get for the rocket itself, right? We don't get to see for the kick stage for some reason. A region that kick stage is kind of hidden from the public. So we will not, that is the reason why we are not seeing the camera views of the rocket also. Like we won't see the deployment of the satellites, but we will definitely see some cool looking animations, which is what we gonna see. And other than that, kind of looking, the mission was successful, right? Now what will happen is the Curie engine will start to it has already separated. The third stage and second stage has already separated. Third stage is nothing but a kick stage. It will host for certain time, and then when the it is in ground range coverage, as well as when the orbital conditions are all right, it will switch on the engine, Curie will burn, and then finally it will reach the orbit. Why did the space shuttle have a smoky launch? Well, they did use a dirtier fuel, I should say that. Well, if you that is because they use a solid rocket booster along with the liquid fuel engine. So today the rocket which you just saw had a liquid fuel engine, okay, and the liquids are way cleaner than the solids. So solids have their own advantage because solids are very less complex to make, provides great oomph which you need during the start of the launch, and kind of is what you desire from a booster stage, right? So the space shuttle used those solid rocket boosters, and those solid rocket boosters, they don't burn cleanly. They do leave a hell amount of smoke when they burn. So yeah, they do that. But SRBs have this advantage of giving so much oomph very quickly and without having so much complexity built into it. But the problem with the solid rocket booster is that the mileage, it's not giving a good mileage for a 1 liter gas there. So one of the reason is that, and the other reason is it's very hard to control. Once you switch on this SRB, boom, you can't turn it off, which you just saw right now with the liquid fuel engine, because you just can't shut down the fuel supply for SRB, solid rocket booster. So yeah, yes indeed, like a flare. Yeah. Obviously it was using hydrogen and oxygen as its fuel, so when they both react, they give out two times water. So it's like 2 molecules of hydrogen reacts with a single molecule of oxygen to give us 2 molecules of water. Yep, 6 days left for the relativity launch attempt, and I hope we actually get to see the launch this time. And I'll stream that also, so do tune in for that. I hope that's gonna be the launch where this channel's what should I say, virginity loses, because I haven't seen a rocket on this channel which have been successful on their very first launch. I haven't streamed that, so it would be very, very good if I can see that.
Welcome back to the live webcast of Rocket Lab's 34th Electron mission, Stronger Together. I'm Likita Satrasala, and this is Felicity Powell, and we're glad you could join us this evening. Our mission has been by the book so far, with the vehicle lifting off at 18:38 local time or 22:38 UTC from LC2 on Wallops Island, Virginia. Electron passed through max Q, MECO, first stage separation, and second stage ignition before reaching the T plus 3 minute mark.
At T plus 6 minutes 16 seconds, the vehicle completed a successful battery hot swap and then followed up with SECO and separation of the kick stage at 9 minutes 14 into the mission. The kick stage proceeded on its first pass of an elliptical orbit and is now completing that coast phase. Up next is payload deployment of those 2 satellites for Capella Space. Let's take a look at this animated simulation of what that will look like and listen back with Mission Control.
Yep. So we are just see those kick stage. Can you see that now? This is what you get. They don't really make us see their show as actually I should say their kick stage, but yeah, you can see those animations. So this is how their satellites are actually stacked together in the kick stage. Looks kind of cool, right? And now one of them can whoa, so these two are actually connected or hosted, I should say, side by side. And well, now the deployment can happen anytime. The engine ignition, the engine shut off is already initiated and should have happened already. We are waiting for the deployment confirmation. There you go. Oh, look at that.
Deployment confirmed.
So they both release at the same time, and then just look at that separation, man. That was cool.
And that's Mission Control with the good news. We have successfully deployed Capella's satellites to orbit. And with that, we've completed our 34th Electron mission. A massive thank you and congratulations to our customer Capella and all of Rocket Lab's teams for another mission success. And of course, thanks to you and everyone who has followed along at home to share this moment with us.
This concludes our broadcast this evening, but remember to follow Rocket Lab's Facebook, Twitter, and Instagram pages for more information on our next mission. It might be happening sooner than you think. This is Rocket Lab Mission Control, signing off.
Oh, okay. Finally. Oh, look at that. This is just the launch site. So guys, thank you. This was like a good launch finally, which has come to an end, and they were able to launch it. The Rocket Labs mission is most of the time successful only, and it was successful also this time also. So it was amazing to see that we got to see some beautiful looking shots. Let me see if we have any thing else I need to share it with you guys. A second. Nope, nothing. So okay, cool. So thank you so much for tuning in, guys. It was an amazing experience having you all. And guys, I'm a bit sleepy right now. It's 5 a.m. here. I haven't slept. I have to go to work at the morning. So 9 in the morning I'll have to go to work. So I'll go and sleep. So thank you so much for tuning in. And the next launch coming up, let me just see that, inform you so that you can be ready for that, right? It's hopefully on 18th of March, which is sooner than expected. Whoa, okay. So tomorrow only, I guess. Tomorrow only. No, that's a Starlink launch. So yeah, day after tomorrow we'll have tomorrow only we'll have SES 18 or 9 and 19 launch from SpaceX. Well, I have to see for that. Will I be able to stream that or not? If I'll do, you'll get a notification. But thank you so much for tuning in. Until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and before that, I always forget. Thank you so much, Google account and John Zelinka, for sponsoring this channel. Without their help, this wouldn't be possible, so I always forget. And thank you so much for all the Patreons and members also. You guys are great. You always make sure that I uh, wake up from my sleep and deliver all these streams to you. So thank you so much. So until then, this is Priyan Shiroila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye bye.